Okay, this board has everything that it should have, but I am missing J2 here, so it should fail for J2. So we'll go ahead and run this one through and it should come back as a failure. Load and clamp. Start with capacitors. These are the capacitors would have a little bit of issue with reliably detecting polarity due to the large ones here are fine, but the small ones in the beginning have a little bit of issue with polarity due to leaning capacitors or different markings on the capacitor. That seems to be the only component we have issues with. Missing. Checking the position of the dip switch, make sure each position is correct. I'm actually reading the part numbers on these. Okay, that's one of the panels. Now we're on the second, starting with the capacitors. Again, these are the capacitors we're having difficulty with polarity. We usually can detect polarity, but they can sometimes escape bias. The capacitor does have to be there. If it's not there, we will fail. And of course, polarity on the larger capacitors is not an issue either. Switches again, part numbers. And when you're checking for part numbers, it also obviously checks for polarity. Okay, this is going to be the end of this board, and as you'll see, it's going to unclamp and go back to the loading station. It's lowering. We'll run backwards into the inspection area. Watch that light right there. Okay, and you can see the screen above shows you where your failures were. And it shows our ref ID J2-1, which means it's on the first of the multi-up panel. It obviously is missing. Now, while that's sitting there, we'll go ahead and load another board. And as you can see, good boards can continue to run through while the operator determines, do we have a false call on the board that failed, or is it a legitimate failure? Corrective action is necessary, whatever the case may be. In this case, we're missing the component, so we're going to mark it bad. I'm going to push this button here, reject button. If it's a false call, you can hit accept. If it's a true failure, you hit reject, in which case the screen clears up here, and this board can be removed. If we did say that it was acceptable and it was a false call, it would pass through the machine on downstream. See multi-model there. First model was not good, so it used the next model program. The number of models you can have is unlimited. He's got 128 components total. Okay, we got a good part, as you see on the screen, waiting for next, in which case it would pass downstream. In the interest of me not dumping this thing on the floor, I'm going to manually remove it. We have ideally a 100% failure. As you can see on this side, there is absolutely nothing. All on this side, the components that we do have on here, all the polarities are wrong. We have reversed the polarity on everything, and I changed a couple of the dip switch positions here, and all the capacitors are reverse polarity. You will see a couple of the capacitors pass. This is the issue I was talking about trying to detect polarity on these caps here, these small ones. So we'll run this one through and give you an idea. Still, oh, we're ready to go. Let's start here. Okay, I'm going to check the capacitors first. And you'll see the multiple models as well. I believe we have 8 models or so for the small caps. First one failed. Failed polarity. This one should fail polarity. Searching all the models we have programmed so far. That one failed. Oh, that one passed, which should not have passed. That one's missing, and this one I believe passes too, yes. So that explains the issues we have with the false polarity. As you can see, we have these crosses on the capacitors, which kind of makes it difficult to detect polarity as well. That's why we have so many models. And again, it's only with the small caps that we have an issue with that. And of course, we can detect presence, just not 100% on polarity. Most likely we will catch polarity, but not guaranteed. You see going through the models, all these are failing for polarity or plain missing. And on the second app, they'll all be missing. Just looking for them, we're just not going to find them. See multiple models there. Believe that component had 4 or 5 models. And usually models will, any type of component that may lean or reflect differently under light might require multiple models. And again, those are unlimited. That's half of it. We're on the top half now. Everything is missing on this half. You can see it go through every single model for these caps, these 6, I guess these are the S13490-197Hs. I believe we have 8 models right now. Obviously, when everything's missing, it takes a little bit longer because it has to go through every model. Get in there. Okay, the failure is going to go back to the machine and show you, I'm guessing 125 failures or so. And we'll go right through these. In order, in the order that is on this sheet, I have a sheet here with the components. And I'll read them off as we see them up there. C27 failed for polarity, C28, C33. C46 actually passed for polarity, but it should not have. C69 failed. C71 should have failed for polarity, but did not. C89 failed, and then everything else should have failed. 57, 58, 62, 70, 72, 77, 78, 79, 80, 81, 82, 83, 86, J1, 7, 2, 3, 4, 5, 6, 7, oh wait, we already did 7, 8, 9, 10, 11, L1, R6, R304, R12, R13, 40, 172, 176, 179, 184, 187, 191, 49, 173, 177, 80, 85, 88, 92. Switch 1, T1, T2, 3, 4, 5, 6, and 7. TP1 through 4, and then 5 and 6 are checked together right there. That's the first up, and then the second failure, everybody should have failed since everybody was missing. So C27, 28, you got 33, 46, 69, 71, and 89. 33, 46, 69, 71, 89. 57, 58, and 62. 57, 58, 62, 70, and 72. 70 and 72. 77 through 82. Okay, 83 and 86. J1 and J7. J2 through 11, not including 7. Okay, L1, R6 and R304, R40, let's see, where am I at? R12 and R13, R40, 172, 176, 179, 184, 187, and 191, R49, 173, 77, 80, 85, 88, 92, S1, T1, T2, T3, T4, 5, 6, and 7, TP1 through 4, and then 5 and 6. So everything failed on that side.